All right, let's do a quick list of our shortcuts. Right? So if y is a constant, y prime is 0, right?
Not sharing your screen.
Oh, sorry. Thank you. Thank you, Alan. And that's obvious, right? No proof needed there. But if we did do an epsilon delta proof there, it would be very, very simple. Or, I'm sorry, a limit. One. If y equals mx plus b, how do we say the derivative? I'll say d dx of y or dy dx is m. So I'm just trying to use some different notation here so you see it, right? So dy dx, that's the same as y prime. Right? Why does this make sense? Why is there no variable in this derivative? Why is there no x?
It's already x to the 1, so when you take the derivative, it becomes x to the 0, which is...
Okay, in theory, I agree with that, but we don't like to talk about x to the 0 yet. X to the 0 is dangerous when x is 0. So we don't want to use that power rule here, right? I like what you're saying, though, right? We definitely reduce the power. We know that. But what's another reason why this is just a number?
Or taking away the x.
Right, but that's
we put x over x.
Someone who had just said that. Who had just
Me.
said that? Oh, Jesse, yeah. Yeah. No, before that. Who had said the power rule thing?
Noah.
Noah, thank you. Yeah, so Noel, sorry. So I mean, in theory, yes, I agree. We're dividing by x, but I don't really like thinking about taking that power down. What's another reason?
Is it because of the L'Hospital word?
Because of the what, Markins?
Hospital word?
No, and we're doing that today. What is a derivative?
Slope.
A slope. Okay, there's enough reason, but what's true about the slope of a line? It never changes. So there can't be a variable in there, right? The variable would make the slope change as I plug in, right? At 1, the slope is m. At 2, the slope is m. At 3, the slope is m, right? It never changes. It's a constant slope, right? So the function for a slope is constant. If y equals x to the n, here's our power rule. I get f prime of x is n times x to the n minus 1, right? We've got a couple of strange ones coming up now. If y equals e to the x, I can say take the derivative like this, right? And I get y prime is also e to the x. That one I still have to prove to you. It's at the end of chapter 3 that I'll prove it, okay? If y equals ln of x, y prime is 1 over x. If y equals sine of x, y prime is cos of x. If y equals cos of x, y prime is negative sine of x. That's our list so far, right? Going to have that on our formula sheet for sure, right? (1621). Waiting for 2 more students. Let's pick one and do a quick tangent line. Which one?
Y equal ln x?
Sure. Good. What's in my domain? What's my domain of ln?
X is
Real numbers.
Greater than or equal to 0, right? So y equals ln of x, right? for x greater than 0. Greater than 0, right? I can't put a 0 into ln, right? My calculator will say domain issue or low battery. Yep. We know the picture of the ln. If we don't, we're graphing it. And let's pick e as our value. We know e is in there, right? So this is e comma ln of e, right? And of course ln of e is 1, yes? So we want the tangent line at e ln of e. What's the derivative? What's y prime? It's 1 over x. So we've got our x. We said x is e. We know y is ln of e, which is 1. And m is y prime at e, so 1 over e. Everybody okay? Everybody with me? My tangent line is y minus 1 equals 1 over e times x minus e. So y minus 1 equals 1 over e times x minus 1. And it looks like y equals 1 over e times x. There's my tangent line. Everybody okay? So I'll go to Desmos.
Isn't the point ln of e just 1?
Yes. So y equals ln of x. We had the point e comma 1. And our tangent line was y equals 1 over e times x. Boom. Ha! I love it. How we doing? Pretty easy, right? And not just because I had the letter E in there. It was easy, easy. The number E, sorry. The letter E. Cool, let's do a continuity problem. Okay. So I'm going to open a problem from an old test.
Excuse me.
Yes. Mark and
You forgot recording for a sec.
One more time. You broke up
You
there.
forgot to record us.
Oh, no,
Can you hear me?
I'm recording. See the bottom left corner? You see
Now
that
you're
little,
cut.
see that little ticker in the bottom left corner? It's recording, Markins.
Thank you.
Yeah. Thanks for making sure, because I do forget sometimes. Okay, so let's do a continuity problem, right? So I'm going to open up a test from the past. I think I already did the fall 2019 problem. So let me go to the spring 2020 problem. I'm not showing my screen while I'm opening this, but you know where it is. I'm in Blackboard. I'm in our class. I'm in, on the sidebar, you see the folder past exams and etc. Right? It's including exams, reviews, old quizzes, and there's midterms there. There'll be finals there. So I'm opening the spring 2020 solutions. I don't have the test alone, just the one with the solutions on it. And I'm looking at number...
Professor,
Yes,
this is
Pedro.
for this test, like from 1 or 2 weeks from now, or from the test after that?
You're asking me what date is the first test?
No, I know the date is February 25.
Yes.
The problem that we will do now is for the first test or for the second test?
Everything we're doing right now is first test. In fact, we have 2 more sections. So I'll finish everything for the first test Monday.
Okay.
So today we're doing L'Hopital's rule. Monday we're doing limits involving infinity. I don't always put that section on the test, and then we're just doing a bunch of derivatives. So, you like me, I remember when my teachers would be teaching new material that's not on the test, it would drive me crazy. But this stuff is really, I've designed the way I'm teaching it in an order that it shouldn't mess with you, really. Because what are we going to be doing? More derivatives, more tangent lines, right? So it's not, the thing I'm worried about is the chain rule. The chain rule is the tough one. So I will teach the chain rule before the first test, but then I'll reteach it after the test. Because it's that difficult for some students. And my dog is scratching at the door. And I kind of want you to say, all right, I don't have to worry about the chain rule before the test, right? I can make sure I'm ready for the test. And then, the most difficult part probably of the semester. Well, not really, but at this point, it'll be the most difficult part. Okay, I'm torn between finding this test question or letting my dog in the room. Oh, here it is. It's number 7. So this is the spring 2020 chapter 2 exam, number 7. So spring 2020 chapter 2 exam, number 7. Now we did a problem Wednesday. I think I'm correct there. We did a problem Wednesday, and we did 2, right? I did one with a system, and I did one with just the points, correct? Someone remind me. I did 2 continuity problems. One where I just had the endpoints of a line, and one where I did limits. I did the definition of continuity, and got a system, and then solved the system. Am I correct in that? Am I remembering correct? Okay, thank you. So I'm going to do this one with the system because that's what I plan on doing on your test. I plan on giving you one where you have to do the system. Okay? So in this particular one, I don't have to. And if you do enough of the problems, you'll see when you have to and when you don't have to. I think on your homework problem that I'll give you, you'll have to do it. Okay? You'll have to do a system. So here's my problem. I didn't do this one, did I? I don't think I did this one.
No.
Yeah.
No, we did it.
Okay. So for me, I'm a visual person. I want to look at the graph. I know what all these graphs look like, right? I know what each of these pieces look like. So I'm interested in really all of the functions, right, at 1. Well, I guess the first 2 functions at 1 and the second 2 functions at 3, right? So I know e to the x at 1 is e, right? So I can visualize the e to the x function there, right? And of course I've got that open point there, right? Everybody with me? You can see the whole e to the x function there. I know my quadratic, right, goes through 9, right? My quadratic goes through 9 and goes through the root of 3. So this is y1, right? And this is y3. Can you see my quadratic there, right? Hitting a height of 9 and going through the roots of plus and minus 3. And then it's pretty easy for me to see where my mx plus b is, right? Now, do I need that to solve the problem? No. But you can clearly see what that solid green piece that I need to connect. And so easily I could do this one with my just my endpoints of, I gotta let the dog in. Hold on. Come on, Luke. Come on. You want to say hi to the class? You want to say hi to the class? Come on. Come say hi to the class. Come here. Come here. Come here. Come here. Say hi to the class. Oh, you're gonna be fuzzy. Oh, here she is. You can't really see her. Good girl.
She's blurred out.
Yeah, she's all blurred out. She's definitely fuzzy. So we clearly have endpoints here easily of 1, e and 3, 0. So it's easy to solve this using just my knowledge of the equation of a line, right? Get the slope, get the equation, and then you'll have the b value. But let's do it with the system just so we see it again, okay? So we're interested at what 2 points, and that's clear from the domain. What 2 points are we interested in making the connection?
1 and 3.
1 and 3. So at x is 1, we'll work on our definition of the limit. What do I do first? Plug in 1. So I find f of 1, and it's pretty clear that I use L2, right? I use Y2. I use that second machine at 1 and at 3. So I get a times 1 plus b is just a plus b. Is everybody comfortable with that? So I plugged in x is 1 there, right? I also have to do the limit as x goes to 1 from the left, right? From the right is the green line. From the left is e to the x, and I want that value to be a plus b. So from there I get e to the 1.
No, hold the brakes for a second, Professor.
Yep.
Are you sure 4 minus x squared graphs at
9 minus x squared.
9? Okay.
Yeah.
Okay, I was reading that as 4.
Yeah.
My bad.
Yeah, that's no problem. So my first equation here is going to be E equals a plus b, and that's going to be my first equation in my system. Is everybody comfortable with me here? Everyone following? Nice, lots of nods. Thank you. I appreciate the cameras on. For 2 years, I've been looking at a screen of names. It sucks. It's funny. I go to my face-to-face class. I can't see anybody. It's a mask-to-mask class.
Sea of masks.
Yes. All right. At 3, right? At x equals 3, I need to find f of 3. Well, that's 3a plus b, right? Again, I'm plugging into x there, right? Remember my definition of continuity. I got to find the point of the function. I got to find the limit and make sure they match. And that's what I'm doing. I found the point of the function, right? I got to find the limit. So now my limit is x goes to 3 from the right of 9 minus x squared. And that value should be 3a plus b. And that gives me what? 0, right? 0 equals 3a plus b. Don't let me go too fast there. Make sure you agree with me that I get my system like this. Four, 8, 12, 16, 21. Still missing 2 students. Yesterday, on Wednesday, we had perfect attendance. Everyone okay here? Nice. Now I got to solve my system. I generally prefer elimination method, but you can do any method you want, right? Like, for example, you could do substitution method. You could solve for a in the first equation and plug it into the second equation. Whatever you want to do is fine with me. You don't have to do your algebra like me. You just got to make sure you get the same result, right? So I'm just going to subtract here, right? So what do I get? I get e minus 0 equals a minus 3a plus b minus b, right? I took my first equation and subtracted my second equation. So I get e equals negative 2a, or better yet, a equals negative e over 2. So that's my slope. Everybody with me here?
Yeah, but I just understand you get like e power 1 equal e.
Anything to the first power is itself, right? 2 to the 1 is 2, e to the 1 is 2. Pi to the 1 is, pi to the 1 is e, pi. E to the 1 is e, right?
I was thinking like you can replace it by 2.78. That's what I was thinking.
Yes, but that's the decimal, right? Like pi is not really 3.14, but we approximate with that. And by the way, I don't want any approximations on your test. Don't ever put in an approximate decimal for something. Keep everything as exact answers. Nice. Then we just have to find b, so I can have the choice here. I can plug this value into any equation and get the value of b. I'll plug it into the first, right? So e equals negative e over 2 plus b. So it looks like b equals e plus e over 2. So b equals 3e over 2, right? So I'd want to make some conclusion on the test, right? With a equal to negative e over 2 and b equal to 3e over 2, the function is continuous everywhere. And then what else? Then what do I want to do?
Go to the next question.
Graph it. I want to make sure I'm right. I want to make sure
Okay.
every single question on this test, you can make sure you're right, which is nice. So I don't even have to grade it. I know everyone's just going to have 100, right? So I want to graph it. It's really not super necessary that you put in your piecewise function, but I would just do a quick Google search on how to graph a piecewise function on a TI-8384, right? So so y equals e to the x in curly brackets for x less than 1. It's similar on the 83. You do something else in curly brackets. I forget what, but our middle function was y equals negative e over 2 times x plus 3e over 2. And that's nice because you can see it connect already, right? So I probably don't even need to do the piecewise part of it, but I will anyway, between 1 and x and 3. It's really an equal sign there, but it doesn't change the way the graph looks. And then finally, y equals 9 minus x squared for x greater than 3. And there it is. Right? Continuous. Is it differentiable at those points?
Nope.
Not differentiable at those points. If you could look at that top of the mountain there, purple and black touching, you can see me on my skis trying to balance. I think I'd rather go down the left side than the right side. How we doing? We feel pretty good about this?
Yes. Yes, can you go back to the whiteboard, please?
Of course.
Okay.
If you need me to zoom in on something, Markins, let me know, okay? Nice. We're doing really well here. I mean, I was happy with the first homework. I think, Abraham, I still owe you the homework graded. Is that right? Abraham? Do I still owe you homework graded?
I'm sorry, could you repeat that?
I still owe you homework. Is that correct? I didn't grade yours yet.
I'm not sure. Where do you check if it's graded or not?
I would send it back to you, email.
Oh, okay.
I think, I think because I asked you to stitch it together, right? So it's not late. You'll still get credit for it. Don't worry.
All right.
You just haven't done it yet.
All right.
All right.
Prophet,
Yes.
your camera disappeared.
My what?
Your camera.
Oh, thanks. I like that. I did teach one semester, one day with no camera. I didn't show my screen or anything. I was like, see how you feel.
Just imagine the math in your head.
Exactly. Okay. We have one new thing to do today, and then we're done. And it's L'Hopital's rule. Okay. So we're talking about our new topic today. I think it's section 4.5. So it looks like hospital. L'Hopital was a French, I guess, he had a hobby of math, but he would hire other people to prove theorems, and then he would buy them and put his name on it. This is actually a brilliant piece here for limits, but we don't really know who proved it originally, but we name it after the person who paid for it. So L'Hopital's rule. It says if f of c equals g of c equals 0, then the limit as x goes to c of f of x over g of x equals the limit as x goes to c of f prime of x over g prime of x. So that's my theorem. And we'll do a couple of examples and I'll prove it. And it's pretty elegant. It's so much quicker to do limits this way than it is to do conjugate or LCD or factoring, right? So much quicker. But the key is here that I need the shortcuts. Right, I couldn't teach this to you right at the beginning. I would need the shortcuts. So we're going to go back and do all of our old homework. For like, you take every problem in that first homework that you turned in, except for the secant tangent problem, right? So do those first 3 problems that you turned in with L'Hopital's rule. Now, on your test, on your chapter 2 test, if I don't tell you do it one way, you can do things any way you want, right? So, but if I tell you do this limit using a conjugate, that's what I want to see. That's what I'm going to grade, right? And if I tell you do this limit using L'Hopital's rule, that's what I want to see. That's what I'm going to grade, right? So typically, you'll see in all my chapter 2 tests, the first problem is a limit, and then by algebraic methods, and then by L'Hopital's, right? So you make sure you go back and do some old limits again, and we'll do a few today. Let's start with our very first limit. Now, be careful here. The warning here is if you already know about the quotient rule, students often mix this up, and they see a quotient and they do a quotient rule. But this just says, if you get a 0 over 0, take the derivative of the numerator, take the derivative of the denominator, and then redo your limit, right? And you might have to do it a couple of times. So every time you get 0 over 0, take the next derivative, right? So let's just do a real simple one first, right? So the limit is x goes to 0 of sine of x over x. We already know the answer is what?
Sine x.
What's the limit of sine of x over x as x goes to 0? My chat is open if you don't want to talk. I almost fell asleep there. Almost hit my head on the desk.
It's going to be a negative sine of x.
No.
It would be like 0 over 0.
Yes, but what is our limit? We did this. Let's see if
Or like is it like indeterminate or something? Like you
yes,
do like
yes it is. I
cos,
still have
cos x over 1. It would
it's
be
one. It's one. It's
Yes,
one. I still have my cricket sounds here. Let me see. last semester, no one would answer me. Everyone was asleep. The cameras were off and they were all asleep, and I just played cricket sounds all day. We know this limit is 1, right? So first of all, sine of 0 over 0 is 0 over 0, right? So question mark. We don't know what that could be. Could be many things. We call it indeterminate, right? So in this case, we can apply a little hop, and I like to put that little hop right above my equal sign, and then say that I'm going to do the limit as x goes to 0 of sine of x prime over x prime. I'm going to write it on my test that I'm about to take a little hop, a L'Hopital. And so what do I get? What's the derivative of sine?
cosine.
Yep. And the derivative of x?
It would be like
1. So I get cos x. I'm just doing the limit of cos x as x goes to 0. And I'm going to try my limit. So that means plug in. So I just get cos of 0, which is 1. So much quicker, right? This was the first quiz I gave my face-to-face class. So my face-to-face class is taking a midterm and a final only, but I give quizzes, right? The quizzes are easier. It's just one question, right? And so the idea is I'm trying to balance two different classes fairly, giving you chapter tests because we meet for an hour and a half, hour and 25. And giving them only a midterm and final because we meet for 2 hours and 15 minutes. So, but they get the quizzes that makes it help the grade a little bit. You get smaller chunks of tests that makes the grade a little bit better. So, but here was their first quiz. I was doing the limit as x goes to negative 2 of x cubed plus 8 over x squared minus 4. Now, to factor this is horrible, right? But if I plug in the negative 2, I clearly get 0 over 0. So I can take a hop, right? So I'm doing the limit as x goes to negative 2 of d dx of x cubed plus 8 over d dx of x squared minus 4. This is just another way of saying take the derivative. d dx is an operator, like square root. What does it mean? Take the derivative. What does that prime symbol mean? Take the derivative, right? So both of these are polynomials, so I should be able to do these derivatives pretty quickly. What do I get upstairs?
3x.
3x squared. Okay. Yeah, 3x squared, right? Reduce the power by 1. And downstairs?
Get 2x.
2x, right? Now I can simplify this, and I would say simplify it. So you've got the limit as x goes to -2 of 3x over 2, right? And so then I'm plugging in my -2. I get an answer of -3. That's a good one for you to do by factoring on your own time, right? Who's got that first homework ready there? What do we do? Number 19. Which one's got the square root in it? Someone read me that one. Oh, I have it here.
It's the 21, I think.
I got it. Pretty easy, isn't it? This is easy, right?
Professor, so this only applies to when the limit that we have to find for one plugged in goes to 0. Comes out 0.
I can use L'Hopital's rule in 2 situations. Actually more, but we'll save a couple of the others for Calc 2. When I get a 0 over 0 limit, or when I get infinity over infinity. And that's going to happen Monday. We'll do that one Monday. And the key is, I do the limit, realize I've got 0 over 0, do the derivatives, redo the limit. Rinse and repeat. Keep doing that over and over. All right, this is number 21 from the homework that you already did, right? So this is 2.3 or 21. I'm doing the limit as x goes to 16 of 4 minus square root of x over 16x minus x squared. When I plug into 16, I get 0 over 0, so I know I'm going to apply L'Hopital's rule, right? I want to work on the side on this one because it's a little bit messy, right? So my side work is going to be just the derivative of 4 minus square root of x, right? So that is 4 minus x to the 1/2 power, right? So the derivative of 4 is 0, and the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Make sure everybody's okay with me there. And I can simplify that. I get -1 over 2 square roots of x. So there's my numerator derivative. And I might as well do the other one on the side as well, right? 16x minus x squared prime is 16 minus 2x, right? That one's pretty quick. But now I can go back to my limit. I'm doing the limit as x goes to 16 of -1 over 2 square roots of x all over 16 minus 2x. There is a way for me to simplify that a little bit, but it's kind of pointless. So I'm just going to plug in right away and see what I get. Whenever I do little side work pieces, I try and box them off. You know, I box things a lot, just like Muhammad Ali did when he went to school. He boxed all his answers. It's a joke.
So if we don't know the limit for 4 minus root x, we just use quotient rule, right?
No quotient rule. I didn't teach you quotient rule. You don't know quotient rule yet. I'm doing L'Hopital's rule. Derivative of the top.
No, I mean if we don't like the shortcut.
No, know the shortcuts. Don't not know the shortcuts. It's a power rule. X to some power. Bring down the power, reduce the power. Do enough derivatives that you've memorized all these things. By Calc 2, if you don't have all your derivatives memorized, you're in trouble. Hey, Udi's here. Morning. So, and I recorded everything, Udi. Don't worry if you... Right? Did you come in?
Okay.
Yeah. So I can simplify this, right? This is minus 1 over 2 times 4, and then 16 minus 32. So it's negative 1 over 8 over negative 32. That's positive, and it's 1 over 128, right? Is that right? No. Help me. What did I do wrong?
I think it was
Oh, it's negative 16.
negative 16.
Yeah. Sorry. But of course, you're going to do this limit on your test. You're going to do this limit with a conjugate. You're going to do it with the L'Hopital's, and you're going to double check numerically, right? And you're going to for sure have that question right on the test. Now, if that's one question, think about it, right? You have no time to sit there and do nothing. No time to sit there and think. Start writing, right? One question, 8.5 minutes to do. You got to do it with the conjugate. You got to do it with L'Hopital's. You got to check it with the calculator, right? One question, 8.5 minutes. It's a lot. You're going to be writing fast. There are going to be shards of paper and pencil flying all around you, right? You'll be writing so fast.
Professor, could you please go back to the previous page for me, please?
Go back to the previous page?
Yes, please.
Yes, let me make sure everyone's done here.
Okay.
Anybody need to stay on this page for another second or minute? Markins and Mob, your cameras are off. We'll go back. Markins, this one?
Yes.
All right, I'm going to prove this. Okay. As I'm doing the proof, I don't care if you write it down really, unless you're a math major, maybe a computer science major, maybe a astrophysicist. The proof is very simple. So, but for the rest of us, we want to just be agreeing. As I write the proof, you should be going, oh yeah, I get that. Yeah, I agree with that. Or what? Wait a minute, Robert. Wait, what? Right? And so, and hopefully we can say yes all the way through my process, and then at the end we've got it proven, right? So, in order to see the proof, I mean, it's not me. I'm not a genius. I got it from my teacher, right? So I'm just a good copycat. Actually, I practiced a lot. All right, I want to prove this. L'Hopital's rule. So we want to remember what we're trying to prove. If f of c equals g of c equals 0, then limit as x goes to c of f of x over g of x equals the limit as x goes to c of f prime of x over g prime of x. I just wrote it again just so I'd have it on one page. And I want to start, in order to prove it, right, so here's my proof. I'm going to let f of c equal g of c equals 0, right? If I'm going to prove to you that I'm a millionaire, then I'm very generous. You got to give me $1 million before I can show you that I'm generous. So if I'm proving something, I've got a conditional statement. We got to assume the first part is true, right? If my name is Robert, then I'm a math teacher. You got to let my name be Robert. That one that actually happens to be false, but right. If if I have a living unicorn, then it has two horns. That one's true, right? If I have a living unicorn, then it has two horns, because I can't disprove that one, right? I can't find a living unicorn. So, but I want to assume that the if part is true and try and prove the next part, right? And what I'm going to do is start with the limit as x goes to c of f prime of x over g prime of x. Well, when I'm taking a limit of, well, I know what a limit is, right? I know what a limit is. I know what a derivative is, right? It's that y2 minus y1 over x2 minus x1 as x2 and x1 go to 0, right? As delta x goes to nothing. So I'm really doing the limit of f of x minus f of c over x minus c and g of x minus g of c over x minus c. Right? So I've taken this derivative and put in that definition of the derivative upstairs. Right? And you see I'm still taking a limit, right? I'm taking the limit of upstairs, I'm taking the limit of downstairs. Well, I don't know if you see it. No, so first of all, we agree with that, right? Just f prime of x has got that definition. Right? G prime of x has got that definition. And you can clearly see if I plug in c, I get 0 over 0 upstairs and downstairs. But I can simplify that. Do you see the keep change flip? Right? This is the limit as x goes to c of f of x minus f of c over x minus c times x minus c over g of x minus g of c. Right? I'm just working with my fractions there, and these guys cancel. That step is easy to agree with. So now I have the limit of f of x minus f of c over g of x minus g of c. But I know something about f of c. What is f of c? It's in my first line of my proof. F of c and g.
Sir, tangent?
Nope, f of c and g of c are 0. Yep, I've assumed nice.
Oh, right.
So I've got f of x minus 0 over g of x minus 0. Well, why bother writing minus 0, right? Waste of ink. So I get limit of f of x over g of x done. QED. QED is Latin for I told you so. Well, let's just do a quick recap of things. Monday is homework 2, right? 5 problems, all with the derivatives as limits, 2 of them with tangent lines, right? You've got test 0 to take. Right, you're going to be getting that lockdown browser in there, right? And what else? Get to work on the Chapter 2 review, right? Get to work on Chapter 2 tests. Yes, work on your formula sheet, right? Sometime next week we'll do that camera view, right? Where I'm looking at from your camera, I can see you, your computer screen, your keyboard, your mouse, your papers, your formula sheet, and the problem you're working on, and your calculator, right? I should be able to see everything.
Professor, you said test 0 is due on Monday.
No, I think I have it set due on the week before the test, like the 18th or something of Feb. Just because I want to make sure it's working before the test, the day of the test. If you haven't done it and the day of the test you can't log in to the test, then you know it's a 0. So we don't want to We want to get a 0 for a technical reason.
Professor.
Yes, Pedro.
The test 0. It like the camera is just like the zoom camera, or the lockdown browser, or like the
test 0 is your just installing your lockdown browser, making sure you can open the instruction file, answer the one question. I don't.
Yeah, the camera.
But the camera is for Chapter 2 test.
Yeah, not that, like, because like I already did things like with like the zoom camera, but like the place that we took the test also needed a camera.
You need your computer, and you need another device watching you take the test.
Yeah, because I have a computer and I have a laptop, but this laptop don't have a camera.
Well, then you can't use it.
No, the question is like I can do the test on the laptop and have the computer watching me.
Exactly. But the problem's going to be: is it a desktop camera? On your camera is a desktop. How are you going to get it? You're gonna tip the monitor, or what are you gonna do?
I can move like the webcam.
Okay, got it. That's fine if you do that. That's fine. I'll show you an example of what I want and what I don't want next week. I'll show you an example live with my camera, and then you'll try and set it up and then show me the next class. Okay? So just keep it in mind. And I'm sorry it sucks. I know that. I do have good news though, and that is it's 9 a.m. and we are done. I like easy Fridays. So have a great weekend. Get some work done. Probably shouldn't have recorded that part, but too late.